Hello everyone, for today we will introduce how to use SPSS to run a MANCOVA test. So for MANCOVA test, it is a multivariant counterpart of ANCOVA. Then it will look for the significance of the main difference among groups. So for the data here today, so then the independent variable will be the teaching method. So we can see from here, methods, the label will be teaching method. Then the values, we can see number one means cooperative learning. Number two, teacher-centered learning approach. Number three, students learning Mandarin with flipped classroom approach. Number four is students learning Mandarin from inquiry-based learning methods. So they are the four values for methods. Also, we can see we have got four groups of students. Then the covariant will be students' education background, so years of education. So it will be, we will check for students' years of education background. Then the two dependent variable, the first one will be students' listening test score. The second one will be students' reading test score. So for this test, we are checking for students teaching different methods, learning Mandarin with different methods, whether we will affect their listening and reading test score or not. So then first, let's checking for outliers and the normality test. So for outliers and the normality test, we will click analyze, then descriptive statistics. So we go to explore. Then for here, we move our covariant to the dependent list, listening test, reading test score to dependent list. So then at statistics, so we click outliers, continue, then go to plots. We click histogram and normality plots with tests. So after that, we click OK. Then for the results in this site, so we can see we got 60, total 60 cases. Then there's no missing data. So from the descriptive parts, we can we can have two, the first way to compute the data normality is check the screwiness and courtesies for the results. So we use the statistics divided by the standard error. If it's within the minus 1.96 to the positive 1.96, if the result is within this kind of numbers, so the range for this, then that means the test will be normal. So then we can check the screwiness and the courtesies. So by both, we checking the results. Then after count, also the second way we can checking for test of normality. So for test of normality, the first one we can check for Kolmogorov. So then the significance data over here, we can see all the results in this part. So when we checking test for normality, we have to make sure we don't have statistical significance here. So then we don't want the significance higher than 0.05. So both the Kolmogorov and the results for Shapiro, the significance is higher than 0.05. So we can know we can continue, because if we have a significant result for this section, we have violated the assumption of normality. So then all our p-values at here, they are larger than 0.05. So we can continue with the analysis. So then the next one is for histogram. So we can check for histogram of years of education. A histogram gives a visual of the results of normality, as do the QQ plots. So then for normal data, the plots should be clustered around the line. So then we can check in both the years of education, then for the plot, box plot, also the same. The line is within the blue box, so it all shows our data are normal. Then the listening test, also the histogram, and then the QQ plots, the box plot, all the data shows normal. There's no outliers. Also, rating test also we can check in the blue box over here, the box plot. There's no outliers. That means we can continue with our test. So then if we have outliers over here, we have to go back to our data and then delete the outliers, run the normality again. So right now we move to the second options. Then the second operation, we go back to we can check for the linearities. So we go to graphs, then move to legacy dialogues, go to the scattered and dot. So over here, then we will click the matrix scattered. So we click define. Then we move, let me reset again. So we move all the three scale values like the years of education, listening test results, reading test results. We move to the matrix variables. Then after that, we click OK. So for this part, we are looking for a rough ellipse shape over here. So we can see all the data over here is gathered in a rough ellipse shape, so we don't see any cause of concern. That means we can continue. For homogeneity, run a customer MANCOVA. So this is a test for the assumptions. Then it's not the final MANCOVA you will run for the test of your research hypothesis. So, but in this step, I'm going to set up the MANCOVA for a few preliminary calculation for the actual test. So let's go back to the data again. Then at here, we click Analyze. Then we go to General Linear Model. We choose Multivariate. So then we move our covariant data, the years of education to covariance, move the teaching methods to independent data to the fixed factors, and then our dependent variables, listening test results, and the reading test results to the dependent variables. After that, we check for EM means. So for EM means, we move the independent variables methods over to the display means for box, then click continue. Then the second step, we will checking for the options. So for the options, check for descriptive statistics, homogeneity test, and then estimate the effect size. So click continue. Then the next one, we will click plots. So for plots, we move the independent variable methods to the move over to the horizontal X box and then click add, then continue. So click model over here for model, then we click the build customer term. So then for the move your factor times variables. So click the methods and then the education. We click them both, then drag to the model. So after that, I want to move our factors and the covariant separately to the model, over the model. So then we move the methods separately and then education, our covariant separately here. So after that, then we can click continue. So then we click OK. So from this part, in the output viewer, look at the box. First one, in the between subject factors, we can see we have teaching methods for different groups. The first one is cooperative learning. The number 2 is teacher-centered. Number 3, flipped classroom. Number 4, inquiry-based learning. Then for the descriptive data, we can see the different means about the results using the different teaching methods. So then the important is we have to look at the box of test. So from the box of test over here, then if the box significance over here is greater than 0.001, that means it is non-significant. So then we will have to use the data over here. We must use for the Wilks lambda, because if the significance over here in the box plot, if in the box test of equality, if they are less than 0.01, 0.001, we will choose p-like trace. But for our data is greater than 0.001, so we choose the Wilks lambda. So over here, the multivariate test, if we scroll down, so Wilks lambda over here, we can check more clear. So the Wilks lambda of the teaching methods, so we can see they are not significant. That means the significant level, the p-value here is larger than 0.05, so we can continue. If you get a significant finding, that means if your data over here, the p-value for Wilks lambda, if it's less than 0.005, 0.05, if they are less, that means your assumption is violated. So then you cannot continue with the test. So we must make sure at here the data is greater than 0.05. It should be larger than 0.05. So we can continue for our test. So we also can check for the test between variables. Then the test between variables, so we had a non-significant results over here. So then for methods and education, test of between subject effects. So over here, we got our non-significant results. So then that means we can continue our analyze. So then let's go back to our data. We perform the test again. So once we do all the preliminary checking, so let's run the MANCOVA. The first one, we will click the analyze. So then we will click the analyze here, move to general linear model, click multivariate. So then since every setting is already been set, so remember we must move our independent variable to fixed factors, covariant move to covariant, dependent variable move to dependent variable. And then after all the setting, we just click model. For specific model, we change from the build customer terms to full factory. So then after we check over here, we can continue. So, and then we click OK. Okay, then we check our output viewer over here. Then the first one is in the descriptive statistics. So we can see our means, and then they do not have a different look between groups. So we don't know, but they do have a little difference between groups, but we don't know at this point if they are significantly different or not. So then, for example, in the descriptive statistics, we can see the listening test results for students who learning with the cooperative learning methods. Their marks is the highest, and then the teacher-centered learning approach is the score lowest. And then for students' reading test, cooperative learning will be the highest. And then the teacher-centered learning method will be the lowest. But we don't know they are significantly different or not. So we have to move to the multivariate box. So then for multivariate box over here, so here we can see if the teaching methods. Okay, here we can see if the teaching methods has a significant results when we control the education. So then again, we are going to use the Wilker's lambda. So because of the box of test equality results, we can check in. For our box of test results, our data is the significant level is larger than 0.05. So we have to use Wilker's lambda. Then right now, so move to the multivariance. We check the methods. So Wilker's lambda, the significance level we can see is 0.005. It's less than 0.05. So we do have a statistical significance here. Then at 0.005. This is smaller than the alpha of 0.05. So then if your findings weren't significant at here, so if in your test, your results is larger than 0.05, that means you cannot continue. But for our test this time, yeah, we did have a significant results. And then we can continue to look at the test results. So over here, for the Levine test of equality of error variance, over here we can check we don't want a significance. So for Levine test over here, our p-value is higher than 0.05. That means we don't have a significant. Then we can continue at this is since this is not significant. So for test between subject effects over here, then we want to check the methods and the listening test and the reading test relationship. So we have a significant value over here. We have a significant result at 0.038. Again, it's less than 0.05. Since our data, the p-value is 0.038, it's less than 0.05. So, and our rating test score, the p-value is 0.044. It's also less than 0.05, which means both our two tests, they are significant. So then we can conclude that the teaching methods has an effect on students' listening test and reading test results when we're controlling for the covariant of students' education. So this is all the interpretation, the presentation of the MANCOVA. So hope you can learn and understand with this one. Thank you.